Okay, so in problem number 8, the setup is that the int type is a value type, array types are reference types, and all parameters are passed by value. Okay, so the difference between the setup between 7 and 8 means that these two integers here, x and y, these are now value types again, which means that we can sort of get rid of the arrows there and just say, well, x is equal to 0 and y is equal to 1. So M is still a reference type. So we still have this arrow business going on there. Um, but x and y are just integers. And so when we copy them in, we're going to copy in the reference to M, but we're going to copy the values of x and y. Okay, so same initial output as in all the others. So let's handle this call. So the first call. So we're going to copy M into A. All parameters are passed by value, but because M is a reference type, that means that we are copying that same pointer. And so basically this becomes a pointer to this array. And this is not going to get too messy because there's only one reference type, right? So B is still a value type, and so that means that we're going to copy the value from X into B, so that's going to be 0, and then we are going to pass the value, or we're going to copy the value of y, which is 1, into C. So that's the initial setup. So then we're going to say, well, A sub B, and now because we have A, which is now an alias for the same thing that M was, it's not an alias directly for M, it's just an alias for the same thing that M points to, or that M is a reference of. So in that sense, they're aliases. And so A sub B, so B is 0, so this is going to change the first element of M, and it's going to change it from a 2 to a 0. Okay, so then we increment B by 1, so that changes B from 0 to 1, and again, this is not having any change on X, right? These are value types, and we've passed by value. So then we have b or y plus equals b. So this is going to change y. It's going to increment it by 1. So that's going to change this into 2, kind of like 5. Problem number 5. And then a sub c, so we're now looking into this array again, and we're doing sub c, so that's going to change this second element, and we're going to set the second element to 8. Okay, so what that means is that when we get back to the main function, um, all this has gone away, and so the output is going to be the first 3 elements of M, which are now 0, 8, 5, and then X, which is 0, and then Y, which is 2. Okay, so now let's do the second call to G. So in this call to G, A will still become a reference to the same thing that M was, because we're passing a reference type by value. And then we are going to copy Y into both B and C. Remember that these calls are different. So B is going to become 2, and then C is also going to become 2. Okay, so now we can just run through it. So A sub B, so A sub 2, so that's going to change this 5 to a 0, or it's going to change, yeah, so it's going to change this, oh, wrong color. So it's going to change this value to a 0. And then we're going to increment y by b. So here's y, it's 2. We're going to increment it by b, which is 2. And so now this is going, so now y is going to be 4. And then, I'm sorry, I forgot to increment b, didn't I? Yes, I did that wrong. So apologies for that. So I forgot to increment b, so that happens before. So b gets incremented to 3, and then y, which is 2, gets incremented by 5, or incremented by 3, which makes it 5. Okay. All right, back on track. Okay, so now we increment y to 5. We do a sub c, so that's a sub 2 at this point becomes 8. So that changes this second value in the array to 8. And so now we're done with the second call to G. And so we can erase all those things. And that means that our output is, again, the first 3 values in M, which are 0, 8, and 8 this time, and then 0, and then 5. Um, Incidentally, this setup is kind of interesting because it's essentially the same as C semantics. So if you remember from 261, remember that we said that arrays were simply arrays are aliases in C, which we can think of as being you can think of it as the array name essentially being a pointer to the array itself. And so that's just the way that arrays are stored in C. And so in some sense, you can think of that as a reference type. It's not sort of a true reference type because it's a pointer, and under the hood, pointers can be manipulated, but C doesn't let you do that with array names. It's a little bit complicated. But essentially, this setup is similar to what you would see similar to what you would get with if the program were written in C. So if that helps you to think about what we just did, then maybe that's helpful.